Hi, I'm Jason Jelks, Manager of Software Development for Sensory Analytics. In this video series, I will guide you through the basics of Kepware tools, how to set up a data tag, as well as how to connect the Opc server and/or plant PLC networks to the SpecMetrix system.
In this final tutorial, we're going to go over wrapping everything up, tying it all back in, and mapping the Kepware configuration that you create into SpecMetrix so that your PLC and plant can talk to the SpecMetrix system. As we saw in the first video, the OPC server is something that we can create, and we can create a device that is a bottom channel. We also have the ability of creating connections directly to a PLC, whether it be Allen Bradley, Siemens, Mitsubishi. We can create a connection into these PLCs as well, and we can create devices that actually talk to a specific PLC at a specific IP address and their division assignment. So what we want to do now, we want to import tags. We want to talk about importing tags into the OPC server. The way you import a tag is you will simply right-click on the device, in other words, the bottom or bottom line. We will select Import CSV, and we will choose the correct CSV file that contains the setup we want to use. When we've selected that, we will see that this automatically gets filled in with all the information that we have pre-saved in our device. And this is very easy when it comes to OPC. We can set these up on the fly immediately without having to have any actual physical device available. For PLCs, it is not as convenient. You actually have to have a PLC device, a proper one that is going to match up with the PLC device that is going out to a plant. We only have Allen Bradley as far as our setup controls for testing. When we want to set up a PLC, like I said, you initially have to have a PLC to connect the first time. There are two different ways of grabbing information for PLCs. The first off is we can go into the properties. If we're connected to the PLC actively, go into tag generation and click on the create tags. And what that will do, that will immediately talk to the PLC, provided it is connected, and extract all the tags from the PLC and store that internally. We're going to import a pre-configured PLC. I'm selecting the bottom, so I will choose bottom, open. I've also got a top, so this could be a two-line system where we have top and bottom. And so I will import the top tags as well. And as you can see, inside of my system, I've already got everything configured and set up for my process. How I want to see this, how I want to work with this, the information that it contains. And there is all the data that I can use. Now, when it comes to tying tags in for our PLC or OPC server, we can also use a pre-configured OPF file. It is a bit different in that it actually allows us to save an entire process, including tags that are already set up for us. Therefore, I do not have to make any changes at all. Now, making the connection into the OPC or PLC directly from our tool, which is this SpecMetrix, the OPC integration tool, we need to do two things. First off, we need to create a new line and at least one new probe. Depending upon how many probes your systems have, you could have 2 or 3 or 4 probes, and you simply just click on the plus sign to add a new line. And you'll notice that as I change between one line or another, the probes that are selected are associated to it. And that is because a line contains probes, and the probes report directly to that line. It's the hierarchical feed of information. And this matches exactly what we have created in the Kepware side of information. To see our Kepware tag from this tool, we will simply click on Helpers, select OPC Servers, choose the OPC server that is currently connected, and you would want to choose the Kepware Server EX, whichever one, version 5 or version 6 that is on your system, and load the Kepware tags. We will see that when we expand out the Kepware by clicking the plus sign, we see our OPC and our PLC information already here. As we expand out each one of these values, we can see the tags that are saved in those particular areas. What we want to do in this case, if we're connecting to OPC, we would simply take our tag information and drag it to the appropriate areas. It's important to note that when we're looking at where we drag and drop these, there are designations as far as the plant input section and the SpecMetrix output section. In the SpecMetrix output section is strictly information that SpecMetrix will write. None of that information is ever read from the source, whether it be the PLC or OPC. So a plant making a change into that information would not add any benefit for their functionality. When we expand the output data section, you can see we've broken up our UDTs into segments. So we have alerts where we've got our condition code, so we can drag and drop the condition code. In this version of software, we no longer constrain ourselves to having to have things spelled or in the exact same format. You do not have to define your controls in this easy to follow hierarchical fashion. You could put them all in one control, one UDT if you like. That just makes it a lot more difficult for your mapping later. And so we try to make things as easy as possible all the way around. We can continue by mapping this the rest of the way for this particular piece by clicking and dragging and dropping and just finding out what our date of occurrence is. Obviously, that's the last updated. And you want to just, use some common sense when you're creating these, and that way you know things are either appropriately or inappropriately getting set. As you can see, if we expand out all the items that are available, either read or write into the SA data section, there is a lot of information that we're supplying, a lot of information that can be consumed by the plant. This does not mean that every one of these fields or tags need to be established or defined. In fact, you only need to define the ones that you care about and map them. There are certain items, certain tags that give very specific information that is pretty critical to understanding the operational state or functionality of SpecMetrix. And as we get to some of these tags, I'll define those and highlight them accordingly. In the first set of tags, the primary thing that we're looking at are inputs in this case. We have 4 primary structures: the Basecoat structure, and that is only if you're doing subtraction of a base coat underneath a primary coat or a top coat. We have the recipe name. That is without a doubt the most important piece to our system if you're going to automate. Without a recipe, there's no way for us to know what wavelength of light we're measuring in, or what the coating that we're trying to measure, or the parameters of that coating. The run bit, again, parallel pretty closely to that, is the ability for you to start and stop the system. And I'm just going to continue mapping through here while we go through this process. The rest of these, encoder position, lane definition, line speed, those are optional. Lane definition is only used for traversing systems. As you can see, you have different aspects of encoder because we do have our primary system and our configuration that maps to many different types of hardware. You will often see many fields that don't represent anything to you. In this case, blown film applications do not present to anything in a standard line, and so those would not be pertinent in your scenario. For traversing, there are additional web dimensions that you can present. Edge trim, independent lane, segment or region count, and web width. The 2 most important on these are going to be web width and region count, as those will define how wide the web material is that we're measuring in a traversing system and how many lanes physically you want to divide this into. It is important to note that if you present a number that reduces the lane width size to less than 1 inch, then it will automatically recalculate to be at 1 inch. We do not provide lane segments less than a 1 inch or 25 millimeter segment. Again, as we talked about the recipe for an output, because some of our recipes can actually have multiple spectrums, we isolate out only one of those spectral information so that we provide that to you so you know what you're measuring, so you can have that information to track. And all of these values that we're mapping in right now, they may or may not make sense to you as to what they mean, what they do, but we will cover that in a later series of videos whenever we go a little bit deeper into recipe creation. When we're looking at Allen Bradley specifically, and there could be others, when it comes to creating a string is made up of two parts: the physical characters that make up the string and the length of that string. This is the same for Siemens as well, but it carries a little bit different mapping structure. In this case, Allen Bradley has a specific map for the data that we would actually grab the data and pull that data information up into the tag. So one of those such information is heartbeat. A heartbeat is a bit that SpecMetrix will write every 2 to 5 seconds, and it will change it from 0 to 1. That way you know that you have communication going back and forth between SpecMetrix and the PLC. This is typically not used in the OPC, as the OPC is local and on board to the SpecMetrix system. The second such bit that is also important is the is running bit. Is running lets the PLC or the PLC programming understand that the SpecMetrix machine is actively measuring. So when we have a run bit come in and it turns on, but the is running bit never does, then most likely there was a validation where the recipe name could be incorrect. There might be a problem with the base code or something else that has been an indicator that the SpecMetrix line has failed to start as requested. And so therefore it is important to monitor and look at this is running bit from the PLC perspective and understand that that is your actual indicator as to whether SpecMetrix is truly on or not. And then most importantly is probe data, probe information. These are the actual measurements and recordings that come into your probe. The top information is the standard probe information that contains anything as far as the algorithms for smoothing the process to make sure that we're not getting volatile readings, especially when you have very high density paints, whites, aluminized coatings. And so you will want to make sure that you are appropriately mapping your information into these tags. The Micron value is a very important one if you're trying to understand and correlate information between what SpecMetrix measures, as we measure strictly and exclusively in thickness. Everything about any sort of weight is converted based upon the percent solids by weight, volume, and mass of the coating itself. The read status is extremely important when it comes to understanding is the value that I'm looking at in my measurement and in my Micron value, are those actually right readings or not? If the read status is 0 when it is active, then those values should be considered valid. If the reading status is something other than 0, if it's a 1, a 2, 4, -5, anything like that, then the values in measurement and Micron value should be considered obsolete or old and invalid and not used to propagate into your systems. The other aspect of that is you do have an option as an administrator to turn on a 0 value flow, that if the read status comes in as something other than 0, we will set those to 0. We do understand that there are plants sometimes who that causes an averaging issue, so there's that option to how you at your plant want to deal with that data. The statistics, each time the probe cycle is reading, it reads for 1 second by default. These values here in the stats are the statistical information for one single probe cycle. It is not any sort of aggregation or average or accumulation over time. And again, those are simply mapped by dragging them into their correct position. It is extremely easy to drag and drop something in the wrong position. For example, sensor total count, I can drag it here to max evaluated, and I've got the wrong map data. So it is extremely important to pay attention to what you're doing and realize that if you have something mapped incorrectly, don't panic about it. Just come back into the OPC configuration tool, find out which one is mapped incorrectly, and then just drag and drop and map it correctly. So we have mapped our bottom line. The last thing that's left to do is to make sure that we have properly assigned these lines. The problem that comes in is when you assign a line, it has a name, just like a person has a name. And if your name is John Smith and somebody comes up and says, hey, Henry, you're more than likely not going to respond. And it's the same thing with SpecMetrix. So a line name is important so that when we're talking and we're producing values for the bottom line, we know exactly which line we're talking to. And likewise, the probe names themselves are specific and they do have information that's qualified. So in this case, we would want to make sure we assign the probe name in accordance to what we've set the probe names in the configuration tool. And this could be something as simple as left or right or derecho. It doesn't matter what their name is. It's just that you got to make sure that that name matches what is assigned in the configuration. And that may not necessarily be what is assigned. That very well could be something completely different. Again, there's no requirement that there is matching names at the tag level in the PLC. It's matching information as it's mapped across. This concludes how to map your PLC or system into SA. And if you like this video, please give it a like and subscribe. We'll be doing more videos coming up. Thank you.